Hello friends and a warm welcome to this video. I'm sure you must be surprised about the title of this video, that is Illusion of Knowledge. If you're curious about this title, I think it would be great to make it very clear to have this disclaimer that this is not a clickbait and we're actually going to talk about something called as illusion of knowledge. Now imagine you have been writing a technology for let's say last 5 years. There's a high probability that in a lot of cases you will consider using that specific language as a default without even giving it a second thought. And this is what leads to an illusion of knowledge. So for example, I'll take my own example. Let's say if I have been writing something like let's say Python for last 10 years or last 5 years, then I would naturally be inclined towards writing Python for whatever the use case is. But what happens is that the technology industry is changing very fast. It is changing faster than we are blinking our eyes. And therefore, it is important to adapt. It is important to learn what lies outside of our own comfort zone. We have to understand the fact that 10 to 15 years back, Python or JavaScript were not the most popular language. And if we extrapolate, then it's quite obvious that 10 years from now, or let's say 5 years from now, that won't be the case. So it is important that we are not stuck with the same programming language, even if it is our favorite language, even if it is suggested by somebody whom we admire, even if it is the language which is used by one of the biggest companies in the world. Well, absolutely nothing. So we always have to keep challenging our knowledge. We always have to keep learning new technologies, and that is the objective of this video, to see where exactly we can find this illusion of knowledge and to try to burst it. What are the different methods we can try to burst this illusion of knowledge and to think outside of the box. So how exactly are we going to do it? Well, this is a very simple problem on LeetCode called as concatenation of array. I have already solved this problem in one of the previous videos, but today what I'm going to do is I'm going to conduct a very simple experiment and I'm going to record the observations which I'm going to draw by using this very simple experiment. And you must be seeing that what is ChatGPT doing here, and that too in the premium version. Well, so you may always say that this is the language which I have been writing for years, and it's quite understandable. All of us are not very comfortable in all the languages, but now we are living in 21st century, we are already in 2023, and we have ChatGPT. So in order to just, let's say, do some experiments or perform some experiments, we really don't need to learn a new language, because every language may have its own learning curve. But even without doing that, I think we can draw certain observations, and that's the sole purpose. And similarly, I'm calling this a very nano kind of an experiment, because this is very small, right? So we are going to note down the programming language, the execution time, and memory, something very simple. So as I already mentioned, that this is going to be a nano experiment only. So let's get started. Now, the very first thing which I'm going to do is I'm going to see that what all methods of solving this problem are known to me in my favorite language, which happens to be Python, because that is what I have been writing for quite some time now. Okay, so what we have to do is, the problem happens to be very simple. You are given an array and you have to concatenate that same array. Let's say we are given an array A. We have to copy the array and we have to concatenate the copy to the A array itself. So it's like doubling the length of the array and having those same elements replicated. Now, what are the different methods of solving this which are known to me? Let me start by the simplest one. So let's say I have another array which is called as result. Now what I want to do is this is again one of the most, I would say, the simplest one, but one of the most unoptimized way of doing it. So what I'm going to do is, for I in range, let's say len of nums, what I'm going to do is I'm going to say result dot append nums. Sorry, not nums but nums I, right? Because I want to append element by element. Now for j in range, let's say length nums, result dot append, let's say nums I, right? Again, this is very unoptimized, as you can see. So let me now return result, and yeah, as simple as that. Trying something, first of all, trying something in a very simple way. Now what is wrong here? The output is 1 to 1, 1, 1, 1. Why is it so? Let me just go ahead and check. Okay, because I have written nums I here. So as you can see that mistakes can happen always. Cool, so we have passed this test case. Now let me just go ahead and submit this, and let's see where we are with this in terms of, okay, cool. So as you can see, just by writing some code which appears to be unoptimized, we are able to achieve a 76 milliseconds runtime. Let me quickly go ahead and write it. So programming language Python, unoptimized is, okay, let's not write unoptimized or anything like that. Let me just write attempt 1, or perhaps approach 1. That would be a better idea to write. Approach 1. The execution time was 76 milliseconds. Got it. And this is the amount of memory that we used, that is 16.51 MB. Let's write it here. Okay, now let's just close it. Cool, let's go ahead and use another approach. for Python. Let me just go back to the description of the problem. I hope you have understood the problem by now, and that's perhaps the reason for solving this problem in this very simple way. Now, what could be the next way of doing it? Let's look at that. Let me just reset the code once again. Cool. So one of the ways could be that we can simply say that return nums *2, because Python allows you to replicate things. Now, what is the difference between this and the previous approach? Well, as you can see that I don't have to write multiple lines of code here. In just one line of code, I'm able to return the result. Let me see. So as you can see, the test cases are passing. Now let's go ahead and submit this one. And let's try to observe. Okay, so this time, as you can see that 80 milliseconds is the time which is taken, still beating 84% of the users with Python 3, but 16.70 MB and beats only 9% of users with Python 3. Now, as you can see that a very small difference, even here you were using 16.5 to 16.7, and see the difference. Let me actually show you that. Let me show you the previous one. So here we were able to beat how many users? We were able to beat 78% of the users, right? And here we are only able to beat 9.62% of users. Now I have absolutely no idea about how many users are there and all that, but yeah, at least for the sake of our observation, we can write that this one is taking this approach to which is called as replication. This is taking around 80 milliseconds, and when it comes to memory, I would say 16.70 MB, I guess, if I'm not wrong. Yeah, cool. So this is also accepted. I'll go back to the description. Now we will look at another way of doing it. What could that way be? Let's think about it. So can we say simply nums plus nums? I think this is also possible in Python. We can actually concatenate two lists just like this. So let's see what happens if we do this. Okay, so we can pass this. Let me now just submit this one. Let's see what the result is. Okay, that is awesome. So we are having 79 milliseconds, not a very great improvement. So I can write Python 3 here. This is approach 3, and this is list concatenation. So what we can do is we can write something like how much it was, 79 milliseconds, and this was again I think close to 16.58 MB. Now the first observation which I would like all of you to draw is that just by making some small changes, you are able to beat a lot of users. Like the difference is quite phenomenal, beats 78% of the users when you are using 16.58 MB, and if I go back to the previous one, you were able to beat only 9% of the users if you were using 16.7 MB. Now again, not a very, I would say, enlightening observation here, but still a good one. Cool. Now let's go to yet another method. Let's use the method which is a list method only. So we are going to say nums.extend nums, right? Got it. So let's just go ahead and run this one also. Okay, this is giving me a wrong answer. Okay, the reason being that it's not going to return anything, so I have to now say return nums. Cool. Now let's see the response. Now let's again submit it. This is again very interesting. So this time we are beating 67.95% of users with Python 3. But if I talk about the memory, this operation is very highly optimized. When it comes to memory, we are able to beat 97% of the users just by reducing the memory use by a few more. I would say it's less than an MB, right? If I have to write this approach, let's say Python approach 4, and this happens to be built-in method, built-in list method. So here we are utilizing this much of MBs, and if I talk about 88 milliseconds happens to be the cool. So now you have got some numbers which you can talk about. So based on what we have done so far, I think it's very easy to tell what approach is good when we want to optimize on memory, and what approach is good when we want to optimize on storage. Now if you notice, let me actually zoom this thing a bit. So from 100, let's make it 125 or perhaps 150. Yeah. So as you can see that 76 ms, that is the approach which we thought was not very optimized, like, you know, using 2 for loops then appending one by one. We thought that it would be slightly more time consuming, but at least for these observations we can see that it was very efficient on CPU, it was very efficient on memory also. So I think it was on number 2 when it came to memory. Whereas the last approach wherein we used the built-in list method, we were using 88 milliseconds of execution time, and then memory was 16.47 MB. Now there can be a lot of arguments around this, because one of the things is that if I talk in very technical computer science terms, whether this will be considered a valid experiment or not, well, I think it can definitely give us some hints, but as long as we are not aware of how exactly the lead code environment works behind the scenes, we may say that no, these are not very valid results. Now, but there is one thing which it can definitely tell us, that for a lot of scenarios, I think we can assume that the average load on whatsoever lead code environment is running it would have remained constant, at least throughout the I would say the cycle of these experiments, or throughout the life cycle of these experiments. So what we can say is that these experiments, even though they are not very effective in purely computer science or technical terms, but they can give us some hint about the nature of a given approach and the nature of the given programming language. Now let's move to the second part of this experiment, where we are going to go out of our box, where we are going to go out of Python, and let's experiment with different languages. So I think one of the best things to do is let's see what all languages are supported by lead code and try them out one by one. So Python 3 we have already seen. Now before I go to C++, I think it would be great to go to C, because you're going to learn some very interesting concepts here. Now the code is already written here, because I had actually written this code, but let's say this code is not written. What is it that we can do? We can always ask ChatGPT to write this code for us. So let me actually give this problem to ChatGPT and ask it to write some optimized C code for me. Write optimized C code for the above problem. The reason why I wanted to give this example, or I wanted to share this ChatGPT 4 example, is because in all of the cases, let's say you want to perform some experiment where you're trying to compare two programming languages. You may not know the language in all the scenarios, so it's always a good idea to have a tool like GPT-4 which can write the code for you. So this is quite interesting. Now as I mentioned, that there can actually be a lot of argument around whether this is the best way to experiment or not, but the observations which we are going to make by the end of this video will definitely convince you that whether this technique is technically correct or not, but it is definitely going to add a lot to your knowledge. Now this, even if you were not a C programmer from the background, you would be able to tell now, because you will have to search what is malloc, and you will have to see why exactly we need to handle this, let's say, memory allocation failure, and how exactly are the numbers copied. So you will find that unlike Python, in C language there is absolutely no such concept as a dynamic array. So the array always has to be static, and you will also get some insights if you do a search around what is malloc, what is calloc, and how exactly you have to free the memory. You will realize that in a lot of cases, if you have to assign memory for a dynamic array, you have to, let's say, assign it on heap. So I am using all these fancy technical terms without actually explaining what they mean. The idea is very simple, that when you search about why exactly are we doing this thing here, you will definitely gain some more insights on the internals of C language. But anyways, I think the same code is already written here. So let's try to understand this code, because there are comments here. So as you can see that we are given this get concatenation function. Now here we have int nums. So this is basically a pointer to nums array, and then we have the size of the nums, the size of the nums array. Then we are also given an integer, like basically a pointer to the integer, which is return size. So first of all, we are trying to set the value for this pointer, like we are basically setting a value at the memory location to which this pointer is pointing, and the value is set to num size into 2, because we want to store, we want the size of the new array to be twice the size of the array which is given to us. Now int size of new equals return size times size of int. So very simple, if the return size happens to be 10, let's say if we have to return an array of size 10, what we have to do is we have to multiply that return size into size of int. Like whatever the size of int is inside of C language, we have to multiply it with return size. So as you can see that you have to manually allocate this memory. So people who are coming from languages like Python, they will get a very good insight that how exactly memory is actually allocated. So now we are allocating the memory. So as we can see that malloc is the function which is used to allocate memory. Then what is the other interesting insight? So ultimately here we are returning this array. Now one more insight which I would like to provide you is that whenever we are using malloc to assign some memory or to allocate some memory, we are actually using the space on the heap, because the array which we are, let's say, declaring or defining inside of the function, its life cycle is available only till the life cycle of this function. Once this function is returned, it won't be able to exist, it will cease to exist. And that's why we can only return a pointer to an array which is something we are allocating on the heap, which is outside of the life cycle of this function. And now there's one more thing. Yeah, So this is an interesting note which is given here, that the returned array must be mallocked. Assume caller calls free. So which means that our function did not care about freeing this memory once we have used it, because the caller, whosoever is going to call this function, will actually take care of freeing the memory for us. So like all these things you will understand once you actually try to write this code in a different language, and only by reading this code you will get a lot of insights, a lot of internals. So you can always use ChatGPT to write this code. So now let me go ahead and run this code, because I'm sure that this will actually give us a better runtime than Python. At least that is what we have always assumed. That is very interesting. So now as you can see that it is beating 99.87% of users with C language, and we are using only 19 milliseconds. So we should definitely write this observation that we are using just 19 milliseconds to solve this problem. And in terms of memory also, as you can see that 9.98 MB of memory is what we are using. So 9.98 MB is what we are using when it comes to C language. I don't know what happened with this orientation, so I'm not particularly good with Excel, but yeah, I can do small things. Awesome. Great. So, but still, if you notice that it beats only 21% of users with C. So which means that maybe we missed something, because we have not been a C programmer and we don't have a very good background in C. So let's ask GPT whether it can do something about it. So let me try to be a prompt engineer now. Hey GPT, can you help to optimize the following code in terms of memory? Let's be more specific. So let's see what GPT has to say about this code. So the provided code duplicates the nums array and returns it. There's not much scope for memory optimization in terms of space complexity, since you have to allocate 2 into num size integers. However, the code can be made slightly more concise. Okay, the variable size of new is just an intermediate step and can be avoided. That is interesting. So it has actually given us some code. Let me just copy this code and let me just go back. Let me just paste it here. So maybe let me comment this, because I really don't want to miss these comments. These are very valuable. So here we go, run the code, and yep, let me submit it. So this is a slightly more optimized version, even though okay, it was supposed to be an optimized version. Let me be slightly more precise here, but yeah, as you can see that 31 milliseconds is what it took. But this time, as you can see that just by taking 9.68, what was the memory which we consumed? It was 9.98. So let me write this once again. So this is C language, and we are taking 31 milliseconds. Now comes another interesting insight. So 31 milliseconds, and what is the memory we are consuming? That is 9.68 MB. Cool. So as you can see that this actually gives us some insights into how exactly the world of programming works, at least on LeetCode, that you are able to beat 95% of the users. And in terms of optimization, you haven't done a big deal here when it comes to saving the amount of memory. It is using 9.68, and previously it was using 9.98. So it's just 0.30 MB. Just by let's say optimizing on space by 0.30 MB, you are able to become one of the most efficient programmer out there, because you are able to beat 95.42% of the users who are using C language. And trust me, this code is not written by me, it is written by ChatGPT. So let me then ask it one more question. Can you optimize it further on both time and space? Another interesting question. So we are doing some prompt engineering also side by side, trying to ask more and more questions. And the objective of this video is also to talk about how exactly you can use GPT in a very positive way in order to enhance your knowledge of programming, in order to basically fill in all the gaps which you may think that you have when it comes to the understanding of different programming languages. So in a lot of cases, like you may have a discussion with your peers, and all of you might agree that Python is faster than C. But when it really comes to checking that what is it that is causing Python to be slower and what is it that is causing C language to be faster, then it is important that you have some kind of practical experimentation to support your claims. And I think this video is just a very tiny experiment in that direction, in order to understand that how exactly we can figure out that how things are different under the hood. Okay, so now this is the response which is given by GPT. Given the problem's requirements, there is no way to optimize space because the output requires an array of this. So space complexity will always be this. Okay, time wise you're iterating through the entire nums array once, so the time complexity is this. This is optimal because you must visit every element in nums array to duplicate it. That said, there is a slight trick that doesn't reduce actual time or space complexity, but can be seen as space optimization in certain scenarios. Now we should definitely read what exactly is this slight trick. If you are allowed to modify the input array, you can return the input array as part of the output, thus avoiding the need to allocate additional memory. But in doing so, you are making an assumption that the caller does not need original nums array afterward. Here's how that would look. Not exactly lock, I'm sorry, how exactly that would look. Got it. So now let me just go ahead, copy this code, and let me go back to the description. Now let's try this piece of code as well. So now let's see whether we are able to achieve anything, because this is just a lead code problem. I don't think the caller needs this nums array for anything other than let's say the result of this problem. So let me go ahead and try to submit it and see whether we are able to achieve anything interesting here. Well, I don't think anything remarkable here. So 34 milliseconds, last time it was 31 milliseconds, and in terms of memory, this time it is using 9.76 MB, last time it was using 9.68 MB. So I don't think there is any further improvement here, so hardly making any difference. Now let's go and look at some other popular programming language, and we are already here in the description. So let me go ahead and choose Java, because Java happens to be again one of the most popular programming languages. So as you can see that some code I already submitted. So here what is happening, well, int needs to be returned, so the return type is mentioned here. This happens to be a public function, and get concatenation is the name of the method which we are going to call on the solution class. And then we have got int nums, which is passed to us. Now we are saying that int result. So essentially, I mean, I think this part is very easy to understand for everybody, and that's perhaps the reason why we have taken this problem only, that is concatenation of array. So this is how a new, I would say, new array allocation is happening in case of Java, where we are saying that we are looking for an integer array with, let's say, the length, which is nums.length times 2. So system.arrayCopy happens to be one of the methods which we are using here. And then we are adding all these values to a result variable, which is nothing but an array, and then we are returning that result. So let's see whether it runs successfully or not. Awesome, so it is running successfully. Now let's try to submit this. Amazing. So now you can see I have absolutely no idea why we are able to beat 100% of users with Java. I have absolutely no idea about it. And then we are using 43.91 MB, but we are beating 96% of the users with Java. Now there can be certain hidden details here. Now what are those hidden details? There is a probability that there are less users who are using Java on lead code. That could be one of the observation which we may draw. The other observation could be that the runtime is actually very fast. As you can see that 0 milliseconds, it's kind of, I mean, it's actually putting Java in the league of C language. This is quite surprising for me. So you will have to actually do some research. Now you have actually got that, you know, that illusion of knowledge that Java has to be slower than C. The bubble bursts once again, and we get some more topics to do some research about that. How exactly is it possible that Java's runtime is only taking 0 milliseconds? So we already know that Java uses something called as Java bytecode. There happens to be something called as JVM, but still, how can it be so fast that it is actually going undetectable by lead code? Lead code says that it hasn't taken much time, which means that it must have taken some microseconds, which lead code is not even caring about. It's saying 0 milliseconds. So that is very interesting and adds a point of research for us. But at the same time, if you see that it is taking more memory, I think, than any other language has taken, 43.91 MB. If you see even languages like Python, which are often criticized for the fact that they are using I think 28 bytes for things as simple as, let's say, a basic type like integer, and everything in Python happens to be an object. Even such a language is using just 16 MB, whereas when it comes to Java, we can see that it is using 43.91 MB of storage for the same program. So 43.91 MB is the storage which it has taken, but this is very surprising. I should actually do a highlight here that it is using only 0 milliseconds. That's quite interesting, and this is Java for you. Interesting result. I hope you are liking this video so far. If that is the case, I would request that you subscribe to this channel, because we are going to do a lot of experimentation. This happens to be just the tip of the iceberg, because this is just the beginning, and we will actually do experiments around a lot of different things around computer science. We will also take suggestions from your side. If there is anything particular you want me to experiment around and dig deeper into, then we are definitely open to that. Now comes our favorite language. So when I say our favorite language, what I really mean is that C++ happens to be one of the industry standard languages when it comes to things like gaming, for example. All the games you will find, all the great games you will find, or all the good game engines you will find, or all the browsers you will find, like anything which has anything to do with CPU performance is mostly written in C++. So it is one of industry's favorite language when it comes to time, or I would say CPU intensive tasks. So here is the code. So we have this class solution, and public definitely tells us that this is going to be, let's say, a public function. then the name of the function is get concatenation. It is going to return vector. Now if you ask me what is a vector, well, in C++ we have a vector which happens to be a dynamic kind of an array which can change its size during the runtime. Then we are passing another vector nums here. I think this is a pointer which we are passing because whenever I see this kind of symbol, a pointer is what comes to my mind. And then what we are going to do here is we are actually initializing yet another variable called as a result, and initialize the result with same elements as nums. Now this is a smart move which we have taken. We have initialized the result with the same elements which are there in nums. Now we are saying that reserve enough space for the concatenated array. We are saying result.reserve nums.size times 2. Okay. And then we are saying append the elements of nums to result. So result.insert, result.end, nums.begin, nums.end. Now this is something I really don't want to get into the explanation of. You can definitely search on Google that how exactly result.insert is working here. But then we are returning result. So now let me go ahead and run this program as well. So let's see where C++ stands. Whether C is faster in this specific context, whether C++ is faster. I'm sure both of them cannot beat Java. The reason for that is absolutely not known to me. If you know the reason for that, please feel free to comment about that. But this is very interesting. Okay, I think we missed the page. Can I go back to it? Let me actually submit once again, not a problem. So as we saw that 6 milliseconds, that is amazing. I think this is, if I ignore Java, this is the fastest we have got, 6 milliseconds only. Isn't that very interesting? Now let's look at the memory usage also. 12.59 highly optimized on memory, and we are still beating just 66% of the users. And it is for sure that a lot of users on LeetCode, they use C++ because that is one of the favorite language when it comes to DSA. So 12.59 MB, that is cool, 12.59 MB. Now, given the features which C++ gives, I think it is one of the best languages so far. Very highly efficient when it comes to the execution time, very highly efficient when it comes to memory, like it is using very less memory as compared to the other languages which we have seen. So if you see that Python has consistently taken 16 MB, right, and C took around 9 MB. C is the only language which has been more optimized in terms of memory. But in a lot of cases, we are always trying to reduce the latency, and which is the purpose actually is getting served with the help of Java and C++ in this specific scenario, because the execution time is very less, even though C++ is using slightly more memory than C. So this is very interesting. Now let's look at some modern languages which are, I would say, in a war with C++ to become the language of the future. So let's look at some such languages. Okay, but before that, how can we forget JavaScript? Let's explore JavaScript also. Now comes an interesting use case. We don't have the code for JavaScript, so let me ask my GPT to help me with this. Can you write the same code in JS? So I don't even need to tell it that JS means JavaScript, because GPT has got a great understanding of the context, which is a great thing. And I think it is actually naming the function also the same, which is get concatenation. Yeah, that is quite interesting. Function nums. So nums is being passed. So all that I need to do is, so it is saying nums.concat nums, something very similar to what we did in Python. So let's straight away copy this line, go here and go for this. Now there is one more point which I would like to talk about here, and this is an important point and we can never ignore it. So I started my video by talking about the fact that Python and JavaScript, they happen to be one of the most popular languages around the world. And if you see that in both the languages, it is easy to achieve the result in just one line of code. And it happens to be Python's philosophy also that ease of coding is very important. Whether the code is readable is very important. So in some scenarios, when we are talking about the complexity of a programming language, maybe it's not always sufficient. I'm using the term maybe I shouldn't use it. So I shouldn't use it actually. So in a lot of scenarios, that could be the reason, because if a lot of people know the programming language, then it is, again, that is the only reason why the language is popular, because a lot of people can relate to it, a lot of people can understand it. And if you look at these results, so Python is taking the most time, but at the same time it is able to get you the result in just one line of code. So we really can't ignore that fact about Python. But anyways, let's look at JavaScript now. Okay, so we are able to run the code. Let me try to submit it, and let's see how long is JavaScript taking. Finally, a language which falls in the league of, let's say, Python, because it happens to be taking 63 milliseconds, which is still lesser than I think Python. So let me write JS here, taking 63 milliseconds. But when it comes to memory, it is consuming a lot of memory, which is 44.80 MB. It's quite high if you see. Interesting. Okay, let's move to the next one now. Let's move to those languages which I was referring to when I said that they are contenders for the world's fastest language along with C++. So Golang, you must have heard about Golang. Now Golang is very popular these days, and it is getting used in a lot of scenarios, like ranging from blockchain based applications to systems programming softwares. I would say popular softwares like Docker, they are using Golang, and Ethereum, that happens to be one of the most popular blockchain platform, it is also using Golang. So let's see where Golang stands, at least in our small competition of programming languages. Okay, so let me now try to submit it, and let's see what the result is. Okay, so we are not beating a lot of users here, but we are doing great job when it comes to runtime and memory. So 11 milliseconds even without beating a lot of users. So let me write Golang, 11 milliseconds, and very close to C++, 6.29 MB of memory, 6.29 MB of memory. So if you see that it is beating C also when it comes to memory, whereas it is beating C++ also when it comes to memory. But when it comes to, let's say, the execution time, it is beating only C, because C++ is still slightly faster. I would say at least the execution time, at least in this given context for C++, is around double the execution time for Golang, whereas C++ is consuming double the memory what a Golang program is consuming. That is very, very interesting. So as you can see that a lot of insights we can draw just by performing this very simple experiment. Now imagine if we try to run a similar experiment in context of, let's say, a web application or a small game. We can completely change the game. We can definitely see that which language is good for a given use case. And always remember that whenever you are building a software, you don't have to leave your base programming language. So let's say you are writing a Python based software, you're writing a Django based web application, and you find that there is a certain, let's say, bottleneck. Your application is becoming slower because of so and so code which is written in Python. You can always decide to write that specific piece of code in a different language. You don't have to leave your parent language. As you can see that there are many other considerations when it comes to the choice of the programming language. So the idea is that you can have the knowledge, not the illusion of knowledge, and that can help you a lot. You can actually decide to write the complete web application in, let's say, a language like Python or JavaScript with the help of Node.js, and then later on you can decide that this component is, because it's critical to the success of my organization, I can decide to write it in a language like Golang or C++ or C language, depending upon what application you're talking about. Now, I think we have experimented a lot with at least 1, 2, 3, 4, 5, 6 languages. Let me see if there is any other language which we should include in this competition of languages. Let's see. So we have seen Golang. So I think we should take up some language from the mobile development side as well. So let's go for Dart. Dart happens to be the language. So again, very simple to write. As you can see, return nums plus nums. Now let's see where it stands in terms of performance. So I'm running the code, and now let's see. Okay, so let me submit it, and I'm getting very excited. Okay, so we have found the language which is running the slowest so far and consuming a lot of memory. So 267 milliseconds with the given approach which we have taken. So if I have to write Dart here, so I can see that it is taking 267 milliseconds, which is a lot, and 148.18 MB, 148.18 MB of RAM. That is amazing. Again, another good insight. Now, if you are interested in exploring more, you can definitely further explore Dart. Then we have Elixir, then we have Erlang. So this is again a very popular language. So I have absolutely no understanding of this code, but for the sake of this experiment, I think it's a good idea to give this language also a chance, because this happens to be a popular language for certain use cases. Now let me go ahead and submit the code, and let's see where we are. So yeah, here we go. Okay, that is quite interesting. We got We are able to beat 100% of users in this scenario because there is a high probability that the number of users is actually very less who are using this language on lead code. This is my personal assumption, not an observation at all. So 211 milliseconds. So let me just write this observation also, that with Erlang we are taking 211 milliseconds and 50.60 MB of RAM, which is still lesser than, was it 50.60, still lesser than what we did with, let's say, something like Dart. Okay, amazing. Now let's go ahead. There are many other languages which I wanted to see, but I will leave that as something I will leave that as an exercise for you if you are interested, because otherwise the video will become very long. But there is one language which I really don't want to miss, and that happens to be Rust. The reason being that Rust is again a language which is claiming to stand in the league of languages like C, C++, competing with languages like Go for in a lot of different contexts. So let me go ahead and let me run this program which is written in Rust-Lang now, and let's see where it stands in our comparison. So here we go and submit the last language which we are including for the day. And this is very interesting. If you see, the runtime is 4 milliseconds, beats a lot of users, and even at a very, I would say, small usage of 2.25 MB of RAM, it is only beating just 17% of the users who are using Rust, which means there is a whole lot of improvement when it comes to memory. So let me write this. Rust, which is using just 4 milliseconds, I believe it is, after Java, it is the only language to beat C++, and it is only using 2.25 MB of RAM. Very interesting. So I think the showstopper for today's, I would say, this illusion of knowledge session happens to be Rust. And we should definitely mark it as like in the color of gold because it has won the game. So Rust with 4 milliseconds and 2.25 MB. Now let's look at what kind of optimization it can be if we are able to apply it to a larger context. Let's say if we are able to apply it to a context where we are talking about something like 1 million calculations in an hour, or let's say 1 billion calculations in a day. Things where the scale matters, and it's like the popular term for that is the internet scale things. And there is no surprise, companies like Amazon, companies like Google, and a lot of other tech giants, they are going towards Rust for a lot of their things, for a lot of projects which are happening. So Rust definitely has won the game here because the memory consumption is very less. It's just 2.25 MB of RAM and execution time on top of, like, if you compare it with something like Python, it's magnitudes of order faster. It's taking 4 milliseconds, whereas Python was taking 80 milliseconds. Now compare it with something like that, I think that's not a fair comparison at all. But still, if I compare it with C++, it's running 1.5 times faster, which is great. So with this, I think the only illusion of knowledge which we have actually been able to burst here is that Rust can definitely be a future-proof language, but there are many other things to consider apart from just, let's say, the technical side of the game, because we saw that wherever we had things like if I talk about Python or JavaScript, we saw that we just had to write one line of code, which is not the case with languages like C++, C or Rust. But the question is that, are you willing to learn languages like Rust? If you're really willing to create an impact, if your code can actually run faster than the code which is written by somebody other than you, then that definitely gives you an edge, at least at some point, when you are building some innovative solutions. If you're talking about, let's say, some simple web applications, it may not be the case, because there actually it will be very important that how many more people know a specific technology, and that would become the criteria to decide upon the language. But if a lot of people are writing languages like Rust, then it can definitely become an industry standard. This is by no means, I would say, this is not an endorsement for Rust, but this is just the result which we have got, and that too by running a very tiny experiment. We are definitely going to do a lot more sessions where we are going to talk about illusion of knowledge. We are trying to burst the illusion which we might be having, and I hope you will enjoy these kinds of experiments. If there is anything specific you want me to cover and dig deeper into when it comes to computer science, please feel free to comment and let me know, and I will see you in the next video. Till then, take care and bye bye.